we're going to do a little bit of mathematical vector algebra. We have two vectors, vector A, which is magnitude 3 at negative 50 degrees, and vector B, which is magnitude 5 at 165 degrees. And since no other information is provided about that angle, we can assume that that angle is given relative to the positive x-axis. So that's our standard, unless additional information is provided regarding the angle. So we're interested in what is vector C, where C is equal to A plus B. So with vector analysis, mathematical addition of vectors, we have to break them up into their horizontal and vertical components, and all three components if we were looking in 3 dimensions, and add those components independently and then put them back together. So let's do that. We'll look at vector A, and we'll look at both its horizontal and vertical component, and we'll look at vector B and its horizontal and vertical component. Now, since we are given that angle with respect to the positive x-axis, we know that the horizontal component is just going to be the magnitude 3 times the cosine of negative 50, and the vertical component is 3 times the sine of negative 50. And for vector B, the horizontal component is 5 times the cosine of 165 and 5 times the sine of 165. So if we're looking for vector C, we're going to sum those values up. So let's look at what each one is. 3 times the cosine of negative 50 is 1.93, and 3 times the sine of negative 50 is negative 2.30. And 5 times the cosine of 165 is negative 4.83, and 5 times the sine of 165 is 1.29. Now those should all make some sense. So negative 50, that's the fourth quadrant, and I should have a positive horizontal value and a negative vertical value. Good. 165, that's the second quadrant, and so I should have a negative horizontal value and a positive vertical value. Good. So at least they're consistent with what I expect. Now that they're in their individual components, we can add them mathematically. So we can just add the numbers. 1.93 minus 4.83, and I get for vector C, a horizontal component of negative 2.9, and negative 2.3 plus 1.29, I get a vertical component of negative 1.01. All right, 2 negative components. Good to just do a quick check. That's quadrant 3. So my angle out of that tangent that we're going to do better be consistent. We better be thinking about that. All right, so the magnitude of C, the magnitude value, the size, the length only, is our horizontal component of C squared plus our vertical component of C squared. I'll take the square root. So we have the square root of minus 2.9 squared plus minus 1.01 squared, square root of that, and I get 2.9 squared plus negative 1.01 squared, and take the square root. We get a magnitude of 3.07, and if we're looking at significant figures, 3.1. All right, so 3.1 in magnitude, and my angle is the inverse tangent of the vertical component over the horizontal component. So we have the inverse tangent of negative 1.01 over negative 2.9, and that is 2.9, 19.2 degrees, but that says quadrant 1, and I said it's got to be in quadrant 3, so I'm going to add 180 degrees to that, and I do not need my calculator for that, I get 199, 0.2 degrees. All right, so 180 plus 19 is 199. All right, so magnitude of 3.1 and an angle of 200 degrees. All right, good job.